Welcome to The Explainer. Today, we're jumping into one of the biggest challenges in the entire world of AI, getting a machine learning model out of the lab and into the real world. Why is it that so many incredibly promising AI projects just fizzle out?
How big is the problem? Well, it's huge. A survey from Algorithmia found that a staggering 55% of companies that have poured time and money into AI haven't successfully deployed a single production model. Think about that. More than half. It just goes to show you, building a model is one thing, but making it survive out in the wild is a completely different beast.
And this quote it absolutely nails it. So many teams pop the champagne when a model is deployed, but that's not the finish line. That's the starting gun. That's the moment your model starts facing the chaos of real-world data. So how do we fix this? How do we bridge this massive gap between a cool experiment and a reliable business tool?
Okay, so here's our game plan. First, we're going to really dig into that deployment gap. Then we'll introduce the solution, Mlops. From there, we'll walk through the Mlops Lifecycle, unpack its essential capabilities, look at what the path to success looks like, and finally, get into why all of this really matters.
So what is it that makes deploying machine learning models so incredibly difficult? Why do so many projects get stuck in this limbo? The simple answer is that ML systems are fundamentally different from traditional software. It's about so much more than just code.
You know, most of us are familiar with DevOps, right? It's a fantastic discipline for managing one core moving part, code. But MLOps? MLOps has to juggle three constantly shifting things at once: the code, the live data that's feeding the system, and the model itself. That's what makes it exponentially more complex.
And that complexity introduces a whole new set of challenges you just don't find in regular software. Take concept drift. Imagine you have a model trained to predict fashion trends. If it was built on data from before 2020, its logic is basically ancient history now. The world changed, so the model's performance has decayed. Or what about reproducibility? Trying to recreate the exact conditions to get the same model 6 months from now for an audit, that's a massive headache, but it's absolutely crucial for governance.
So how in the world do you manage all this chaos? Well, that's exactly what MLOps is for. And it's not a tool you can just buy off the shelf. It's a discipline. It's a set of engineering practices designed specifically to tame that three-headed beast of code, data, and model.
What it really boils down to is this. MLOps is all about bringing automation and quality control to the entire ML process. The whole point is to make sure our models aren't just clever experiments that work in a lab. They have to be tough, they have to be scalable, and they have to actually deliver on the business goals they were created for.
And this visual here shows that collaboration perfectly. You've got data engineering on the left, feeding clean, curated data into the system. In the middle, you have ML engineering, which builds and deploys the model. Then, on the right, you have app engineering, which actually uses the model's predictions. But the magic is in that feedback loop at the bottom. The application sends business results back, creating this cycle of constant improvement. MLOps is the glue, the connective tissue that holds this entire thing together.
All right, so let's take a closer look at how that collaboration actually works in practice. The Mlops lifecycle is what turns this from a theoretical idea into a repeatable, automated pipeline for shipping reliable models.
Okay, I know this looks a bit complex, but stick with me, the flow makes a lot of sense. It all kicks off with a trigger on the left, maybe new data comes in. That automatically starts the continuous training pipeline in the middle, which crunches the data and trains a new candidate model. That model gets evaluated, and if it's better than the old one, it gets pushed to the model registry on the right, all ready for deployment. The key thing here is that every single step is automated and tracked. This is MLOps in action.
We can actually break that busy diagram down into these 6 key stages. It all begins with data ingestion and validation. You got to make sure you're not feeding garbage into your system. Then, data transformation gets that data ready for the model. Next comes the fun part, model training and tuning. After that, a super important step, rigorous evaluation. If the new model passes the tests, it gets officially versioned in a model registry. And the whole thing is driven by continuous monitoring of the live model, which can trigger this whole cycle all over again.
So, what do you actually need to build a life cycle like that? Well, you need a specific set of technical capabilities. Think of it as the essential MLOps toolbox for building industrial-strength AI.
A truly mature MLOps platform has all of these functions covered, whether it's one single system that does it all or a collection of best-in-class tools stitched together. The important part is having a solid solution for each piece of the puzzle, from your very first experiments all the way to live model monitoring. Let's zoom in on two of the most critical tools in this toolbox. First up, the model registry. Honestly, without one of these, you have pure chaos. You've got different model versions, saved on people's laptops, no one's sure what's actually in production. It's a mess. A registry fixes this. It is the single source of truth that tracks every model version, its performance data, its lineage, everything. If a new model goes haywire in production, no problem. You can instantly roll back to a previous version you know is stable. It's your safety.
Next is model monitoring. You can think of this as your early warning system. The scary thing about an ML model is it can fail silently as the real world changes around it. Monitoring watches for things like data drift, which is a signal that tells you your input data looks different than what the model was trained on. It warns you that your model is getting stale before it starts making bad predictions. And of course, you're also tracking the basics like speed and uptime to make sure the service is actually working. It's all about catching problems before they impact the business.
Now, getting all of this set up doesn't happen overnight. It's a journey. And to help organizations map out that journey, Google actually defined 3 clear levels of MLOps maturity, which is a fantastic way to see where you are and where you need to go.
You know, most companies start at level 0. This is total manual chaos, with data scientists just handing off models to engineers. It's slow, it's risky. Level 1 is a huge step up. You automate the ML pipeline itself for continuous training. But the real goal, the gold standard, is level 2. At this level, you have a full CI/CD system that automates the deployment of the entire pipeline. This means you can rapidly and reliably test and roll out new features to your ML system, not just new models.
So after all that, why go through all this trouble? Why build these complex automated pipelines? The answer is simple. Because the payoff is massive. This is what finally turns machine learning from being a very expensive science experiment into a real value-generating part of the business.
To put it plainly, MLOps transforms machine learning from this artisanal, one-off process into a reliable and repeatable engineering discipline. And what does that get you? You deploy better models faster. You can actually trust them to work in production, and your teams can finally collaborate without wanting to pull their hair out. It's the engine that allows a company to consistently get real, tangible value from its AI investments. And this really brings us to the fundamental question that every organization with an AI initiative needs to ask itself. Is our ML project just a fragile science experiment? One that's going to shatter the moment it makes contact with the real world? Or is it truly engineered for reality, built with the discipline to be robust, adaptable, and ready to thrive?